Hi dear students, I am Shukoor, your new physics teacher. I hope you are all secure and safe at your own homes. Due to the coronavirus that's spreading in our nations, our educations are changes to in online mode. That's why you are ready to watch the physics online class today. Okay, today I am handling the 9th standard physics, the first chapter of physics, that is motion. In our everyday life, we see different types of motions. That may be in straight line motion, circular motion, rotation, vibrations, etc. We see some objects are at rest and others are in motion. Birds fly, fishes are swim, blood flows through our veins and arteries, cars, trains, aeroplanes are moves, atoms, molecules, planets, stars and galaxies are all in motion. In other case, an object may be appear to be moving for one person and it will be rest for another person. How? An object may appear to be moving for one person and stationary for some other person. For example, for the passengers in a moving bus, he perceived that the roadside trees appears to be moving backwards. Isn't it? Yes. A person standing on the roadside, he observed the bus along with the passengers as moving. However, a passenger inside the bus sees his fellow passenger to be at rest. Isn't it? Yes. What do these observations indicate? Yes, from these observations, we can define motion. We can describing motion. What is motion and what is the state of rest? Do you know what is motion? Do you know what is state of rest? Yes, just first we are going to discuss that topic. What is motion and what is state of rest? After describing this, you can understand this chapter very easily. I hope all of you are listening my class. Okay, first we are going to describe what is motion. To understand motion, we want to capture the idea of a reference point. Using reference point, we can easily describing what is motion. We are going to describe what is motion using a reference point. Yes, what is reference point? We can describe the location of an object by specifying a reference point. We can describe any object, the location of any object using a reference point. For example, assume that a school in a village is 2 kilometers north of the railway station. If one person asking to you, where is the school in your village? Then you say that means my school is 2 kilometers north of the railway station. In our village, school is situated 2 kilometers north of the railway station. That means you are selected as the railway station as the reference point. For what? To specifying the location of school, to specifying the position of the school. That is reference point. Another example, your teachers are standing here. then how can you specify the position of your teacher? Yes, for example, there is a table. If there is a table here, then you says that the position of teacher 2 meters away from the table. That means you taken as table as reference point. Using different objects, we can specify their position using a reference point. Then we can select any type of objects as reference point to our own conveniences. Okay, therefore, describe the position of an object, we need to specify a reference point that's also called origin. If you select one object as reference point, and this is also called origin. Okay, that may be, you can select any type of object with your own convenience. That may be table or railway station, or you are in a classroom walls, like that. Any type of objects can you select as a reference point. For what? To specify other objects' position. To specify the location of other objects. To specify the position of other objects. That is reference point. Using this reference point, we can describe what is motion and what is rest. Can you explain what is motion? Yes. If the position of an object changes with respect to the reference point, it may be any type of objects. I already says that if the position of the object changes with respect to a reference point, then that body is said to be in motion. If the position of an object changes with respect to other objects, then that means reference object or reference point, then we can say that these objects are in state of motion. If the position of an object does not change with respect to a reference point, then that state of body is said to be at rest. That body is said to be at rest. That is the difference between state of motion and state of rest. Then what is motion? Motion, if the position of a body changes with respect to a reference point, that body is said to be in motion. Then if the position of the body does not change with respect to a reference point, that body is said to be at rest. Understood? Do you understand what I say? Do you follow me? Yes. Most of the motions are complex. Some objects may move in a straight line. Others may move in circular path. And others may take in circular path. Some may rotate and few others may be vibrate. There may be situations involving the combination of these. In this chapter, we shall first learn to describe the motion of an object along a straight line. We shall also learn to express such motion through simple equations and graphs. Later, we shall discuss way of describing circular motion. Okay, first we are going to describing what is the motion of an object in a straight line. Now, I am going to describe the motion along a straight line. That is the simplest type of motion, that is known as motion along a straight line. That means a body moving a straight line path. Okay, we shall first learn to describe this type of motion by an example. Consider a car moves from a point O along a straight line and reaches the point A. That is given in this figure. Observe this figure. You can observe that is the car starts its journey from O, and which is treated as the reference point. And let A, B, C represent represent the position of the object at different instances. At first, the object moves through C and B and reaches A. Then it moves back along the same path and reaches C through B. What is that? The car starts its journey from the reference point O. Then it moves through C and B. Finally, it reaches the point A and come back through the same path, and it reaches C through B. Then, what is the total length covered by this car? What is the total length covered by this car? The total path length covered by this car, that can be represented as from O to A plus from A to C. That is OA plus AC. That is 60 kilometer plus 35 kilometer. That is equal to 95 kilometer. And here the total path length covered by this object or car is known as distance travelled by this car or object. If any object that travelling like this, the total path length that covered an object, if the total path length covered by an object is known as distance travelled by an object. That is the distance. Here, the distance covered by this car, we obtain 95 kilometer. When we specifying the distance, we only specify the numerical value of distance, that is 95 kilometer. There is no direction is specified when we are specifying the distance value. Okay, we need to specify only the numerical value and not the direction of the motion in the case of a distance. Okay, there is certain quantities of motion that can be described by specifying only the numerical value. That is the case of distance. The numerical value of physical quantity is known as its magnitude. That means in the case of distance, we only specify the magnitude of length travelled, that is 95 kilometer. Then can you find out the distance travelled by this car from initial position to final position? Yes, you can find out the distance travelled by the car from initial position where the car starts its journey, that is point O. Then finally it reaches point C. That means the distance travelled by the car from initial position to final position, that is OC. Then what is the length distance covered by this car from initial position to final position? That is a straight line distance from O to C. That straight line distance from initial position to final position of the car is known as displacement covered by this body or car. Okay, what is displacement? Displacement is the straight line distance from initial position of an object to the final position. What is displacement? If a body moves from an initial position, then it covers a certain distances and it reaches another point. Then if you take the straight line distance, that is my shortest distance. The shortest distance or straight line distance from initial position to the final position of that object, then we get the displacement covered by this object. If you specify displacement, you want to specify the magnitude and direction of the motion. And in this case, cars are moves from O to C through A. That is the direction. That means the direction of the car, the motion, direction of the car motions is from O to C. 95 kilometers, this is not 95 kilometer. 95 kilometer is the distance travelled by this car. Then what is the magnitude of the displacement here? What is that? Yes, that is 25 kilometer. Here the magnitude of the displacement traveled by this car is 25 kilometer. That means if car travel from O to C through A, the distance traveled is the magnitude of distance is 95 kilometer and the magnitude of displacement is 25 kilometer. That is the magnitude of displacement. Do you know? Do you understood? Do you understand what is the difference between distance and displacement? These are the two quantities that you must be study when you are studying related to the motion. Next case, can the magnitude of displacement be equal to the distance traveled by an object? Can the magnitude of the displacement be equal to the distance traveled by an object? Yes. Consider the example given in the figure. That means for the motion of the car from O to A. If the car starts its journey from O to A, then the total distance covered by the car is 60 kilometer. Isn't it? Yes. Then what is the displacement of the car traveled? That is also 60 kilometer because initial position is O and final position is A. Then the straight line distance, shortest distance from O to A is also 60 kilometer and a distance covered is also 60 kilometer. That means in this case distance and displacements are equal in magnitude. That means when a body travel in a straight line in same direction, if a body travel in a straight line in same direction, in that case the magnitude of displacement and distance will be equal. In that case distance and magnitude of displacement will be equal. That is the case for the displacement and distance are equal. In another case, during this motion of a car from O to A and it will travel back to B also, the distance covered is equal to 60 kilometer plus 25 kilometer, that is equal to 85 kilometer. Then here the displacement is covered by this car is 35 kilometer only. That means displacement is not equal to the total path length covered by this body. Displacement is the shortest distance from initial position to final position of the body, or straight line distance to initial position to final position of the body. That is displacement. Then can you measure the value of displacement that is equal to 0? Can you measure the magnitude of the displacement that will be equal to 0? Yes. In which case? That is, if the car moves from O, that means origin, or then this car moves to the point A and come back and finally it reaches the same point O. That means what is the total distance covered by this car? The total distance covered by this car is 60 kilometer plus 60 kilometer, that is 120 kilometer. Then what is the displacement covered by this car? The displacement covered by this car means the distance from initial position to final position. Which distance? The shortest distance or straight line distance from initial position to final position. And here the initial position and final position coincide each other. For in this case, the car initial position and final positions are equal in same position. That means the magnitude of the displacement will be 0. That means the magnitude of displacement will be 0 here in this case. If that is the case for the displacement, the magnitude of the displacement that equal to be 0. Okay, that means if a body moves a certain distances and come back to the same initial position, then here initial position and final positions are coincide each other. That means the magnitude of the displacement traveled by this body will be equal to 0. That is the case. Okay, let's conclude my words. In this class, we discussed that main thing, that is what is motion and what is rest. What is motion? With respect to reference point, we can describing motion and rest. What is motion? If the position of an object changes with respect to a reference point, then that body is said to be in motion. If the position of an object does not change with respect to the reference body, that means that body at rest. Then we next discussed about the straight line motion and distance and displacement, the difference between the distance and displacement. What is distance? The total path length covered by a body is known as its distance covered, or the distance traveled by this body. What is displacement? Displacement is the shortest distance or straight line distance from initial position to the final position of a body. That is displacement. Distance and displacement will be equal when if a body travel in a straight line in same direction, that in that case distance and displacements are equal in magnitude. If we specify distances, there is no direction for the motion, only we specify magnitude. In the case of displacement, we specify magnitude and direction. Both magnitude and directions are specified in the case of displacement. Then another case, displacement will become 0 when if a body start from a point, its journey and it is traveled a certain distances. After some time it come back to the same initial position, then total displacement covered by this body, that is equal to 0. Okay, that is the main topic regarding with this chapter, first chapter. That's why I hope you all understood what I said, isn't it? Okay, thank you. Okay, let's watch your follow-up activity regarding with this topic and write in your notebook the answers, and after the online classes you will come back to our school and you can submit the follow-up activity to your teacher.
Dear students, this is your follow-up activity based on this topic, distance and displacement. Question is this: a stone thrown vertically upward travels to a height 6 meters and falls back to the hand. If a stone is vertically thrown upward, then it travels to a height 6 meters and falls back to this hand. Then find the distance and displacement in the following situations. First, A question: when stone reaches the topmost position, we want to find the distance and displacement. When the stone reaches topmost position, what is the distance and displacement of this ball? Okay, a stone. Then B question: when the stone falls back in the hand, if the stone falls back to in the hand, then what is the distance and displacement of the stone? This is your follow-up activity that you have to write in your notebook. Okay, thank you for watching my video.